study in our mechanics lab at our STEM school. I'm Basmala.
And I am Salma.
And I'm Malak.
The first experiment is determining the coefficient of limiting friction of two different surfaces on a horizontal plane. Here is the plane with two different surfaces, the red surface and the blue surface. Our block will make it about to move from surface 1 to surface 2 under the action of applied forces. Each applied force is different from the two different surfaces. We will know that this tension force will equal to the static friction force when this block is about to move. Here are our rules that we will use it. The mu surface 1 will equal to the applied force when the block moves in the surface 1 over normal force. Mu surface 2 is equal to the applied force when this block is about to move from surface 2, the red surface, over the normal force.
This plane contains of two surfaces, surface 1 and surface 2. First, we'll calculate the coefficient of limiting friction force on surface 1. First, we'll start putting weights. We notice that the block is about to move at a mass of 17 grams. By adding the mass of the hanger, which is 5 grams, the total mass will be 23 grams. So mu1 will be 23 over the mass of block, which is 63.72, which will be 0.36. Okay, we will calculate the coefficient of limiting friction force on surface 2. So we'll start adding masses. Here the block is about to move at a mass of 12 grams. Also by adding the mass of the hanger, it will be 17 grams. Then U2 will be the total mass, which is 17, over the mass of the block, which is 63.72, which will be 0.27.
I will introduce you the second experiment, which is determining the coefficient of limiting friction of two different surfaces on an inclined plane. This is our plane with two different surfaces, blue surface and red surface. This block will make it to move from surface 2 to surface 1 under the action of applied forces. Each applied force will make this block move in this surface 2 and surface 1. We will resolve this weight into two perpendicular directions, m1g cosine theta and m1g sine theta. The mu for surface 1 is equal to the applied force for the red surface over the normal force. In surface 2, mu s2 will equal to applied force in the blue surface over the normal force.
Now we will find the coefficient of limiting friction on this inclined plane where the angle is 34 degrees and we have two surfaces. This is the blue surface and this is the red surface. Now we will add some weights here to make the block about to move. Then we can calculate the coefficient of limiting friction. This is the first surface. We will add weights until the object is about to move. 20 grams. Another 20 grams. We will check if the object is about to move. So it's still stationary, so we will add more weight. Now it's about to move and the weight is equal to 45 and the hanger is 5 grams, so the total is 50 grams. Now we will calculate 50 grams minus the weight of the block is equal to 63.72 grams. So we will calculate by minusing 63.72 multiplied by sine the angle which is 34, divided by the normal force. So the coefficient of limiting friction now is equal to 0.27, and this is the first surface. Now the second surface, we will do the same. We will apply some weights until it's about to move. It's still stationary, so we will add more. And now it's about to move. Here is equal to 53 grams. So we will make 53 minus the weight of the block multiplied by sine theta. And divided by the normal force. So the coefficient of friction here is equal to 0.33, and how that shows that this coefficient of friction is bigger than this. At the end of the experiment, we conclude that the coefficient of limiting friction, even if it was in inclined plane or in a horizontal plane, it's identical if the surface is the same. Thank you for watching our video, and don't forget to make
Like,
share,
And subscribe.